Hi, everybody. We are getting into chapter 13, which is paired samples t-tests. So the reason why it says 13 and 14 is because I'm going to talk a little bit about the distinction between the next kind of t-tests. We've already done a single sample t-test. In chapter 13, we're going to talk about paired samples t-test. In chapter 14, those are called independent samples t-tests. And so we need to make sure that we know the distinction between all three of those. To start with, though, let's go ahead and do a clicker question from stuff you already know. So answer this question. When do you use a single sample t-test? Okay, the answer to this is you use a single sample t-test when you have collected continuous data that you want to compare to the population. And the reason why we're making the emphasis on continuous data here is because you collect the continuous data, that's how you get the mean. You wouldn't get a mean on categorical data. That doesn't make any sense. So you get the mean on the continuous data, and you compare that to the population's mean, and that's when we use a single sample t-test. That's different from a paired samples t-test that we're going to talk about today, and then independent samples t-test, that's the next chapter. So let's go ahead and talk about the distinction between these things. You want to compare two groups whenever you use a t-test. A t-test is used when you want to compare two groups. In a single sample t-test, the two groups are your sample and the population. Those are the two groups. Okay, so you have to know your sample's mean, your population's mean, you need to know your sample standard deviation, how many people in the sample, etc. A paired samples t-test, which is what we're talking about in this chapter, when you do a paired samples t-test, also called a related samples t-test, you're comparing one group of scores to another group of scores, but both of those scores come from the same people. So, for example, I want to know how stressed out people feel before and after spring break. So I collect stress before spring break, and then with the same people, I collect stress after spring break. The same people, so their scores are paired. That's why it's called a paired t-test. But notice how that's a lot different than a single sample t-test, because in a single sample t-test, we're comparing one mean to the population's mean. Well, let's say that I don't know the population's mean for stress. And all I really care about is the effect of spring break on stress. So I just measure the same people at the beginning, right, before spring break, and then at the end, after spring break, and I can compare to see if there's a significant difference between those two. An independent samples t-test, also called independent groups t-test, is when you compare two groups to each other when the data come from different people. So let's say that I wanted to see what is the difference between psychology majors and business majors on how stressed they feel. Psychology majors and business majors are two separate groups. These are not the same people. We're just looking at the stress level in one group compared to the stress level in another group. This is a lot more similar to a single sample t-test, but it doesn't have to be the population now. It's two samples. So I take the sample that I have from one group, like psychology majors, and I compare it to the other group like that I have, like business majors. So let's see how well you understand. Okay, do you remember that we've been talking about the sampling distribution of the mean? We've talked about this stuff last time. And you remember that in the single sample, we looked at the mean of means. That's the same as mu, right, for the population. But then we also had the standard deviation of the means. Well, that same kind of concept is going to be used again, but this time we're going to be talking about a paired samples t-test. So instead of discussing this in terms of the mean and the standard deviation, and comparing it to population. So the populations mean population standard deviation and mean of those means, or the standard deviation of those means. We're going to now do the same idea, but with what we call difference scores. So instead of looking at, for example, the standard deviation of the population, which is sigma, now we're going to look at a different standard deviation. So let me show you what I am talking about. In the past, we did these, so I just want you to notice the reason why I have these in here. I want you to notice how similar all of these formulas are going to be. So the z obtained is the mean minus mu over the standard deviation of the population. T obtained, this is the single sample t-test. This is a review. The single sample t-test is the mean of the sample minus the mean of the population over the standard deviation of the sample of means. So that's the standard deviation divided by the square root of n, right? So I want you to look at that, and we'll talk about that compared to difference scores in just a second, because now we're going to get into the idea of a paired sample t-test. The paired sample t-test starts with the idea of a difference. And the difference is very simple. It's a very simple idea. It is subtraction. That's all it is. A paired sample would be me, let one person, and I have two different scores. So, for example, I might want to know, is there a significant difference in the amount of sleep you get after you have children compared to before you have children, right? So, I don't know if you've heard new parents talk about how much they never sleep. It's true, by the way. But if we wanted to do this, we would need to be starting to look at the difference score. So let's say that you found me and you measured my sleep. I had the hours of sleep before I had kids right here, 10 hours of sleep before I had kids, compared to the hours of sleep I get after I had kids, and that's 4 hours of sleep. Okay? So in a paired sample, remember these are coming from the same person. So both measurements are from the same person. In a paired sample t-test, you have to be measuring the same thing 2 times. That's what makes the pair. The pairing is the same person being measured 2 times on the same thing. There's a pair of scores, only 2 times, by the way, a pair of scores, and it's coming from the same person, and it's on the same variable. All right? So the difference is very simple. We're going to use the letter D to represent difference. So, for example, I had 10 hours of sleep before I had kids, 4 hours of sleep after I had kids, and the difference is the after minus the before. All right? I don't really care what order you do this in. It doesn't technically matter, except one will give you a negative t score, the other will give you a positive t score. It doesn't particularly matter as long as you know which one is bigger, but traditionally you do the second, right? You do the after minus the before. Okay, you do the second minus the first. So 4 minus 10 gives you negative 6. Negative 6 is my difference. Simple as that. Now, we need to talk about the concept of D bar. D bar is not the mean of one sample, it's the mean of the differences between two samples when those samples are paired. So, same ideas, but instead of just one person, now we have more than one person. So this is me, I'm person 1. I slept 10 hours before I had kids. I slept 4 hours after I had kids. My difference score is negative 6. Negative 6 because 4 minus 10 equals negative 6. This is person 2. Person 2 slept 8 hours before they had kids. Then they slept 6 hours after they had kids. 6 minus 8 equals negative 2. The mean of the differences, is negative 4. So negative 6 plus negative 2 equals negative 8 divided by 2 gives you negative 4. So that is D bar. See this right here? D bar. The mean of the differences. This is important. The mean of the differences is D bar. Okay? So remember, in a paired sample t-test, we always have one measurement at one time, and then the same variable being measured in the same person a second time. The difference between those two is the difference. And then when we add those up, we can get the average of the differences. And that's what we're going to use for a paired samples t-test, which gives us this. This is the formula for a paired samples t-test up here. T equals D bar minus 0 over the standard deviation of D bar. Now, D bar, remember, this is the mean of the differences. So time 2 minus time 1, and then you add them all up and divide by n. Okay, that's the mean. Now, if you remember when we talked about z-scores and single sample t-tests, we were comparing our sample to the population. really what's happening here is we're comparing what we have to the null hypothesis. So let's say that I have a theory that having children makes you sleep less. That's my theory. Okay, I think it's a pretty good theory. What I'm saying is that there is a difference between time 1 and time 2. There's a difference between sleep before you have kids and sleep after you have kids. The null hypothesis would be that there would be no difference, that overall the differences would equal 0. That is, the mean of the differences would equal 0 between time 1 and time 2. 0 is my null hypothesis, in the same way that the population's mean was the null hypothesis for a single sample t-test. So all we're doing is taking what we're getting minus what we expect the null hypothesis to be. And then we divide that by the standard deviation of d bar. Now, just like the standard deviations we talked about last time with z-test and single sample t-test, it's not a straight standard deviation of d bar. It's the standard deviation of the differences divided by the square root of n. So the standard deviation of differences, that's s sub d, that's what that means, and then divided by the square root of n. That gives us the standard deviation of the mean differences, or d bar, standard deviation of d bar. All right? Okay, now that we have these, let's go ahead and test you out. I want you to look at some data. So the data that we are going to use include, let me find them, these data right here. Let's say that I have a theory, a hypothesis, that studying increases your GPA. So GPA 1, this is everybody's GPA before they started studying. Now, I know that sounds weird, but let's say that I had a specific study technique. I think that, I don't know, that studying while listening to Mozart is going to improve your GPA. Okay, so before people study listening to Mozart, this is their GPA. These are all the same participants. Notice that this is participant 1, and this is participant 1's GPA before they started studying with Mozart. Then, let's say a year later, I measure their GPA again. This is their GPA after they've been listening to Mozart while they study. Notice how it's the same person. Participant 1's GPA before Mozart studying, participant 1's GPA after Mozart studying. So each one of these people has 2 scores. It's a paired sample. These are the pairs, right? This is paired with that, the pairs. So what I want you to do is I want you to calculate T based off of these data. The first step to calculating T, paired samples t-test, is to get the difference. Now, remember that the difference is the second one minus the first one. Now remember, I don't particularly care that you go in that order as much. It'll just change the sign, right, of what's going on. So you'll see what that'll do in just a second. But traditionally, you do the second and then minus the first. So 0.5 is the difference between 3 and 2.5. 3 minus 2.5 equals 0.5, the difference. And then I do that for everybody. Okay? That is the difference. All right. Now, I need the mean of the differences, but I also need to get the standard deviation. So let's first get the mean. The mean of the differences is just the average, right? The average of all of these difference scores. D bar is what we are calculating right now. This right here, 0.39, that is D bar. That is D bar right there. But besides the mean of the differences, we also need to get the standard deviation of the differences, and we're going to divide that by the square root of n. So in order for us to do that, we have our difference scores right here. Then we need to get our normal standard deviations. So I'll show you how we're going to do this. So this is going to be the standard deviation of the differences. So we can do this in two ways. The standard deviation, and since this is a sample, it's going to be this standard deviation right here. That's what we're going to get. But that's the same way that we calculated standard deviation every other time. Okay? So what we do is we got all these difference scores. We got the mean of the difference scores. Let's go ahead and do everything the way that we normally did. Okay? The way we normally did was to calculate each one of these separately. So let's go ahead and take a look at what that would look like. Whoops, that's not the one. There it is. Here's what I've done. This is all of the data in the way we normally get it. So these were all the different scores we calculated before. That's the mean. These are the deviations. Same way we've done deviation every single time, but now this is the deviation of the difference. It is 0.5 minus 0.39, and you get 0.11. That's the deviation. We get all those deviations, then we square all those deviations. We add them up, that gets us the sum of squares. So this right here is the sum of squares. Sum of squares divided by n minus 1 is our variance. And then when we get the variance plus, and get the square root of the variance, we end up with the standard deviation of our difference scores, 0.4049, which should be the same right here as our normal standard deviation that we saw before. Same thing. We've calculated exactly the same way we've always calculated it. All right, then if you remember, we need d bar minus 0, which is d bar, okay? So d bar minus 0, d bar is 0.39, minus 0 is 0.39. And then we need to divide it by the standard deviation divided by the square root of n, okay? N is the same n that we've already talked about. It's just the number of people. It's the number of pairs in this case. N is 10, the same thing. Don't try counting up each one of the individual scores. It's not 20. N is not 20. N is 10 here. So what we're going to do is we're going to take this standard deviation divided by the square root of 10. So I don't know if you can see this up here, but it is that divided by the square root of 10. And when you do that, you get 0.129. And so when you take the mean minus 0 divided by standard deviation divided by the square root of n, you get 3.011905. That is our T statistic. Let's practice one more time. I'm going to change the data and I'll let you try it out. So now let's go ahead and change these and see what it does to our data. So now we're going to go through these. I'm just going to change them up. Let's say this is 2, and then I'll make that one 5. It can't be 5 because it's GPA. 3, 2, and then let's change a couple of these as well. And let's change that to 2.0. Okay. Now calculate everything the same way with these data here. Okay, in order to do this, it's pretty simple. All you need to do now is you take this, this mean, this is d bar right here. It's the mean of the differences. The mean of the differences minus 0, because 0 is the null hypothesis. So 0.31 minus 0 is 0.31. But don't just divide it by the standard deviation. We need the standard deviation divided by square root of n. So let's get the square root of n. Square root of n. So equals square root. And the square root of n equals 10. Right there. So now we need the standard deviation divided by square root of n, which is the standard deviation divided by square root of n is 0.25. That makes t is going to be the mean minus 0 divided by the standard deviation divided by the square root of n, 1.233. Okay, thanks everybody.